All right, welcome back. This is Mr. Bosky again. Be crazy with someone different, but it's me. I'm back again. So this is 2.3, linear equations. We have the same essential questions as before. So let's get right into it. So we have the y-intercept and the x-intercept. It says where it's the graph crosses the y-axis. So what's the ordered pair? Where does the graph cross the y-axis? Well, you can see it crosses the y-axis is the up and down one. It's going to be crossed right here. What's the coordinates of that point right there? Is it 2, 0 or 0, 2? It is 0, 2. Okay, if you're still struggling with that, remember, if you don't go left or right at all, you're going to stay there. It's going to be 0, and then you go up 2, it's going to be 2. The left number is left or right. The right number is up or down. Okay? X-intercepts where it crosses the x-axis, which is not really perfect here, but it's going to cross right here. What's the coordinates of that point? That one's going to be 3, 0. Okay, so those are the intercepts. All right, different forms of a linear equation. We have slope-intercept form, y equals mx plus b. M is going to equal what? What is the measurement of m going to be? That's going to be, started with an S, is the slope, right? And b is the what? It's the y-intercept. Right? This is slope-intercept form right here. It's got the slope, it's got the y-intercept. I kind of gave it away here. Here's m, here's b, right? Standard form is a little bit different. It's going to be ax plus by equals c, and a, b, and c are going to be not numbers. We're going to put integers, which is positive and negative whole numbers, right? Okay, so you can just move stuff all to one side, like all the variables to one side. That's going to be standard form, and a needs to be positive. Some people don't really enforce the a needing to be positive, but sometimes we need to do that. So we want you to be prepared that sometimes teachers want to enforce that, so we're going to enforce it too. And x and y must be on the same side for slope-intercept form. So you would have y equals mx plus b. You could do like y equals 2x minus 4, and you could do 5x minus 2y equals 17 would be an example of standard form. Okay? All right, identify the slope and the y-intercept of the lines. To identify the slope and the y-intercept, we need it to be in slope-intercept form, which is y equals mx plus b. So we need to get y by itself in this equation here, right? So what will be the first step to getting y by itself for x plus 2y equals 7? We're going to subtract x. 2y is going to equal, I'm going to put x in front, negative x plus 7. Now what? This is all for y. Divide by 2, divide this whole side by 2. So now we're going to get y equals, what's the slope of this? I see negative x over 2. How can I rewrite that with a slope in front of the x? Well, it's like a negative 1 in front of the x, so we're going to have negative 1/2 x plus 7/2. Okay? That's how you rewrite something when you have a weird slope going on here for this. Okay? It's negative 1/2 x. So what's our m? What's our b? M is negative 1/2. B is going to be 7/2. And that's our answer. Okay. Now, next one, we have y equals negative 9. This is a Hoy-Bucks problem. We have y equals, it's a horizontal line to 0 slope. Well, if it's a 0 slope, we can rewrite this as what? Instead of y equals negative 9, we got to put x in there. What am I going to put in front of the x to make it the same equation, basically? I'm going to put 0x. I'm going to do y equals 0x minus 9. Okay, remember Hoy-Bucks. Let's go through Hoy-Bucks really quick. Horizontal line. 0 equals the slope. Y equals a number is what the equation's going to look like. That's where we get the y equals negative 9. That is what it looks like. It's y equals a number. Then we have Bucks is a vertical line. It's an undefined slope. And it's x equals a number is what the equation's going to look like. Okay, so what's our m and what's our b for this problem over here? M is going to be 0. B is going to equal negative 9. I'll pause here for a second or just wait a little bit. I went kind of fast there. Just such exciting stuff. I just love it. Okay, don't forget Hoy-Bucks. People always goof that up, and it's kind of an important topic that will help you keep those straight. All right, a couple more examples here. On the back page, we have y equals 2/3 x minus 1. For example, 1, it says to graph it. Okay, well, let's graph it. So the easiest way to graph it is to find your m and find your b. So what's our m for this problem? It's going to be 2/3. And what's our b? It's -1. Okay. So the easiest way to graph something in slope-intercept form is to graph the y-intercept and then use your slope to find other points on the line. So if I'm graphing a b of -1, is that going to be up 1, left 1, down 1, right 1? The y-intercept is up or down on this axis right here. So it's going to be down 1. We're going to go down 1. We're going to put a point right here. That's our b. Then our slope, we're going to use this. This is our rise over run. Rise over run. Right? 2/3. So it's going to be a rise of 2. Is that up 2 or down 2? We're going to go up 2, and then we're going to go a run of 3. We're going to go right 3. Okay? If you go up 2 and left 3, that would actually be a -2/3 slope. You got to be careful. You always want to go to the right if possible. So we go up 2, right 3. We can also go, if we run out of room over here, we can go, instead of going up 2, right 3, we can also go the exact opposite direction, which is down 2, left 3. Right? Down 2, left 3. And there's our line. All right, there we go. Number 2, I feel like, is even easier because it tells you what the intercepts are, and we just got to graph the intercepts and connect them. So an x-intercept of 2, it crosses the x-axis at 2. Well, where is that? Well, this is the x-axis. Where's 2 on the x-axis? It's like a number line, right? 2 is right here. Boom. There's our x-intercept. A y-intercept of -5 is on this axis, up and down. Where's -5 on the y-axis? It's going to be up 5 or down 5? Down 1, 2, 3, 4, 5. And now we have our line like this. Okay. That one didn't even require any work. All right, now we got one a little bit trickier here. I'm going to write down a couple more, instructions here. It says find the intercepts and graph the equation. So we have 5x minus 2y equals 5. We need to label the intercepts. Okay, so to find the x-intercept, plug in 0 for y. And then likewise in the opposite direction to find y-intercept, plug in 0 for x. This is a shortcut, okay? Especially when it's in standard form like this, when you have ax plus by equals c, this is a really easy way to find the intercepts and graph it. And graphing the intercepts is probably the easiest way. You could also solve for y and do it that way, but I think it's easier just to find the intercepts. Okay? All right, so let's split this in half here. Let's find the x-intercept over here and the y-intercept over here. So to find the x-intercepts, and the reason why we can plug in 0 for y for the x-intercept, if it's 0 for y, that means it's not going. That means we're looking for where it is on the x-axis, because what's the coordinates of this point right here? Well, this coordinate point is 1, 0, right? What's this point right here going to be? It's going to be 1, 2, 3, 4, 0. What's this point way over here? That's -3, 0. So you can see on the x-axis, the y value is always 0 because it doesn't rise or rise or fall at all. So that's why we plug in 0 for the opposite one. Same thing goes for the y-intercept. What's this point right here going to be? This point right here is going to be 0, 2. This one's going to be 0, -1. Okay, so on the y-axis, that means that the x value is going to be 0 because we're not going left or right at all. It's going to be right on the middle. Okay, so that's why this kind of works, but it's kind of a shortcut. So we have the x-intercept. We're going to plug in 0 for y and solve for x. We have 5x minus 2 times 0 equals 5. Another shortcut that I didn't mention here is you can just cross this off. When you have something times 0, it's going to go away. We just have 5x equals 5, but we're plugging it in here for the first time here. So we have 5x minus 0 equals 5. So 5x equals 5. Divide by 5, we're going to get x equals 1. Or it's going to be coordinates of 1, 0. So that's the x-intercept. But like I said, if you're looking for the x-intercept, just cover up the y. You can see I'm drawing it over here. Just cover up the y, and you'll have 5x equals 5. You can solve it. If you're looking for the y-intercept, you cover up x, you get negative 2y equals 5, and you can solve it. But if you want to go the long way and write it all out, that's a good way too. So now we have 5 times 0 minus 2y equals 5. I'm going to get rid of the 5y. It's just going to be negative 2y equals 5. Okay. 5 by negative 2, we're going to get y equals negative 5 halves, or that's going to be negative 2.5. And it's going to be 0, negative 5 halves. It's going to be that's our y-intercept. Okay, so looking for the x-intercept, you plug in 0 for y. Looking for the y-intercept, you plug in 0 for x, and then you solve, and that's going to tell you where they cross. So we got x equals 1. So on here, we're going to do x equals 1. We're going to go right 1. There's our x-intercept, that is. And our y-intercept is going to be down 2.5. So we're going to go down 2.5, put a point, connect them, and there you go. You could also have solved for y by subtracting 5x and getting like the y-intercept by itself here, but getting y by itself is going to make it really hard to figure out the x-intercept that is. So it's actually a good idea to solve it this way by plugging in 0 for the opposite value that you're looking for. Okay? And that is the end of 2.3. Good job, and we will see you soon. Wrong thing.